Hello everyone, welcome to our Olympiad math training camp. Today we're gonna learn the third topic, number theory. It is a frequently tested topic in many math Olympiad games. So now let's see. Question number 1. What is the value of x so that the four-digit number 3,700 something is divisible by 12? Let's see if a number is divisible by 12. That means when we divide 3,700 and something into groups of 12, there is nothing left. If we can divide it into groups of 12, in every single group, we can also divide it into groups of 3 or groups of 4. So because 12 equals 3 times 4, as long as we can prove 3,700xx is divisible by both 3 and 4, we can prove that this number must be divisible by 12 based on the definition of divisibility. So now let's see. If a number is divisible by 3, what kind of property does it have? Actually, if you have ever learned this topic, you will know we need to check the digit sum. The digit sum is also divisible by 3 when that number is divisible by 3. We can prove it really quickly. If there is a number ABC, a three-digit number, we can split it into 100A plus 10B plus an extra C. If so, 100A includes 99A's plus 1 extra A, and 10B equals 9B plus extra B, and plus 1 more C. Because 99 and is divisible by 3. 9 is also divisible by 3. So actually, we just need to check, is the sum of A, B, and C divisible by 3 or not? We can ensure if A, B, C, the three-digit number, divisible by 3. So that's how we get. To decide if a number is divisible by 3, we need to check if the digit sum is divisible. Let's move on to the 4. Because 4 times 25 equals 100. 4 and 25 are called multiplication paths. They're really useful. Also, in divisibility, we can use it. Like if there is a number, a four-digit number, A, B, C, D, we can always split it into something times 100 added by the last two digits. Because 100 is divisible by 4, so actually we just need to check if the last two digits, CD, is divisible by 4 or not. So when we want to prove if a number is divisible by 4, we need to check the last two digits, if the last two digits are divisible by 4. Based on this, let's see when x equals 0. Is 0 divisible by 4? Yeah, it is. There's nothing left. That means it's divisible. But if x equals 2, is 22 divisible by 4? We will have a remainder 2. So it is not. But when x is 4, 44 is divisible by 4 equals 11. And for 6, 66 is not divisible by 4. There will be a remainder 2, so we can eliminate option D. When x equals 8, 88 divided by 4 equals 22 with nothing left. So when we check if that number is divisible by 4, we can exclude option B and D. Now let's move on to 3's divisibility. We need to check the digit sum. 3 plus 7 plus 2x equals 10 plus 2x. As long as 10 plus 2x is divisible by 3, it is what we want. So 10 plus 2 times 0 equals 10, but it's not 3's multiple, so we need to exclude A. Then when x equals 4, 10 plus 2 times 4 equals 18. Wow. 18 is divisible by 3, so that is just what we want. Then, when x equals 8, the digit sum is 10 plus 8 times 2 equals 26. It's not divisible by 3 again. In this way, we can get, actually, only C can meet the conditions. So that's why we pick C. Question number 2. It's related to another number's divisibility. What is the value of C so that the 4-digit number 1870C is divisible by 9? For 9's divisibility, when a number is divisible by 9, it's almost the same as 3. We need to check the digit sum. But this time, we need to check if the digit sum is divisible by 9. Because let's see, it's also easy to prove it. If there is a number A, B, C, D, a 4-digit number, we can also write it into 1000A plus 100B plus 10C with another D. It's a ones. So we can split it into 999A added by another A equals 99B plus 1 more B and 9C plus 1 more C added by another D. Now you can see 999, 99, and 9. All of them are divisible by 9. So we just need to check, is the sum of A, B, C, D divisible by 9 or not? Then we can get if the original number divisible by 9. That's why for 3 and 9, we need to check the digit sum. Now let's see this number, 1870C. So let's add these numbers together. We will get 16 plus C. If so, which number among 0, 1, 2, 3 added by 16 equals 8 equals 3's multiple? You can just check it really quickly. 16 plus 0 equals 16. It's not 3's multiple. 16 plus 1, 17. It's not 3's multiple. But 16 plus 2 is just 18, 3's multiple. So C is correct. And D, 16 plus 3 equals 19. It's not 3's multiple again. That's how we get C is correct. If we are familiar with several numbers divisibility, we can solve these questions in a really efficient way. It's the same for question number 3. We are gonna solve a question related to 9's divisibility again. How many 2-digit numbers are there such that the sum of 17 and the 2-digit number is divisible by 9? Let's see, first we need to decide the range. Which kind of number shall we discuss? We are discussing the sum of 17 and a 2-digit number because the smallest 2-digit number is, great, it is 10. So we need to start with 27. And the biggest 2-digit number is 99. So the biggest sum we need to discuss is 116. In other words, we need to check from 27 to 116, including these two numbers on both ends. How many numbers are divisible by 9? Actually, every 9 numbers, there will be a nice multiple. If so, we just need to check how many numbers are there, and then divide them into groups of 9. Now, let's see. If we use the last number minus the first number, remember to add the 27 back, because it's also 29's multiple. We need to consider that. In this way, we can get 90. Then divide 90 into groups of 9. We will get 10 groups. In this way, we can get there should be 10 numbers meet this kind of condition. That's why we pick B. Also, you can use another way, like list all the numbers that can meet this condition. or just find how many numbers are 9's multiple from 1 to 26, and how many numbers are there from 1 to 116 are divisible by 9, then do a subtraction. Both are acceptable. So that's how we solve this kind of problems related to divisibility. So hope you can master them and solve this kind of problem more efficiently next time. See you then. Bye.